memorize that? Can that replace my test grade? I'm not kidding.
In your heart.
In your
No.
He did say if we did master set chapter 6, that would be extra credit.
No way.
Yeah.
Yes.
He said we could do it for fun. And just
Master
read
Sex,
answers. I was like, we
Master
should do it for
Sex
extra credit.
6 is extra.
Thank
credit.
you.
Okay, cool.
We don't actually have to do it, but if you do it, if you.
You said it was only
We have to actually answer
When does it
all of
do?
Because if you don't do like half of it and you think it'll, like half of it will give you an extra credit, it won't.
Or no, we don't
So-
test.
I will count it if it
Right.
helps, I won't count it if it
But he
doesn't.
never said a due date, so I just think.
I'm
It's
gonna
on
try my
Monday.
hardest to finish it here.
Do you want like a certain date that the chapter 6 should be due? The master said that extra credit? Because next week, the chapter
We might as well just turn everything.
4 and 5, the next one is on Monday, and then we have the test on Wednesday. So when should be, if we're turning in the chapter 6 for extra credit, when should that be due?
End of next week?
Okay, that's
So next Thursday?
Sure.
Okay.
Wow, we have 3 weeks left of this class.
I'm gonna cry.
All right.
You're gonna join.
It's a joy.
We're almost there.
Not that I won't miss you, Dr. Fox. But
Yeah.
Fun class, but
this class kills me.
like it's a fun. It's like a.
kills me.
It's a
I'm dead. Like, you know how many words I wrote yesterday for that master set?
200.
Now you're laughing. Like, this is just 4 questions.
It's actually 7 questions.
No, if you looked at my paper, I only did 4.
Oh, okay.
All right, moving on.
That bad?
No, it's easy. I just had to write it 3 times.
Let's calculate the mass of the earth.
Yeah.
And we'll do so by looking at the moon. We derived it yesterday, but it felt like we sort of rushed. So, force diagram of the moon.
Oh, the weight is down. Or
Gravitational force.
Yes.
oh yes, grand.
Not exerted weight at this point. Gravitational force. There we go.
You should have had a text wireless.
Anything else?
Positive would be down.
Okay. Do we decompose anything?
No, awesome.
The decom?
Why is it not weight? I know I said gravitational force, but.
Weight is the word we use when you're near the surface of the planet, and the moon is too far away to really be considered weight.
If we accidentally put weight when we have this on the test, would you dock off points for that?
Ultimately, it depends upon, if you plug in mg for the force, yeah, I'm probably gonna count off of that one, unless you happen to know the acceleration due to gravity of the moon as it orbits the Earth. Not the gravitational acceleration of an object on the moon, but the moon itself relative to the Earth. It becomes very difficult to get little g when you start, at pretty much, at the point where little g becomes hard to know, that's the point when you stop calling it weight. All right, decomposition. That seems a head shaking no there. Abigail, you look like you want to say something?
There's nothing to decompose, is there?
No, there's not. All right, we are now with, so we've done, the equations of motion. F equals ma. So if Fg is equal to the mass of the moon times the acceleration of the moon. And put a little c there because circular orbit. Substitution, big G, mass of the Earth, mass of the moon, over r squared. This is the orbital radius, it's not the radius of the moon or the Earth, it's the orbital radius. It's the distance from here to there. That's r. Is equal to mass of the moon times v squared over r. Mass of the moon cancels out, which is why we're not finding the mass of the moon using this.
You're finding mass of Earth.
And so mass of the Earth becomes RV squared over big G. So R can be found experimentally, but I have the convenience of looking it up here. Radius of the moon's orbit. So R is 3.84 times 10 to the 8th meters. Speed of the moon. Ooh. Distance of
Where is that?
what I don't have is
Oh.
orbital period of the moon. Yeah, so I guess we'll go with that.
I said
All right, so the period's about 28 days.
On the top? And I just multiplied it
So we can figure out the speed of the moon by distance over time, and the distance, 2 pi r, over the time of the period. And most of this we hit last time. If I plug this in for V, I have R times 2 pi r quantity squared over t squared g. So I have 4 pi squared over g r cubed over t squared. Question more?
Why is t squared? I'm confused about all your squared cubed.
I'm squaring the speed,
Right.
and the speed is 2 pi r over t, so everything, all this gets squared.
Okay, where are we getting pi from?
We're assuming a circular orbit, and I know the radius of that orbit, and so that is the circumference of the circle. It's the distance divided by the amount of time it takes for it to go around once. Ritika?
So, where are we gonna use the 28 days?
That's the period. That's how long it takes for the moon to orbit the Earth.
Okay, so we
Ish.
substitute it when we need to find the mass.
Yeah, that goes in, it'll go in for big T. So if I just do straight plug and chug for the mass of the Earth, 4 pi squared over 6 point, and let's just double check that, 6.67, what did I write down last time?
6.027 times 10 to the negative 11 power.
It's 6.672. Well, rounding 6.67, I think so adjust your notes accordingly. It's Newton meter squared, kilogram squared, times the orbital radius, 3.84 times 10 to the 8th meters cubed, divided by what?
28 squared.
What do you got?
I got 4.274 times 10 to the 34
What units go with that?
meters. Or no, because, kilograms. Because you cancel everything out, so.
We had something times 10 to the 34th?
Yeah,
Anyone else get the same thing?
I could have put it in wrong.
I wouldn't be surprised if that's right. If you calculated it correctly based on that, I will say that.
Well, what's the answer again?
4.274 times 10 to the 34.
Yeah, I got the same one.
Okay, cool.
So when does the book say the mass of the Earth is 5.98 times 10 to the 24th?
You do something wrong,
With the book or with,
the calculations.
Yeah, so what would be wrong?
Would it be the period?
What about it? It's not 28 days? Are you claiming it's not 28 days, or there's another issue?
There could be a different issue. If that's why our calculations are off, because aren't we supposed to get the answer that you have in the book?
Somewhere close enough to it.
Yeah.
4
Yeah, 4.27.
I got a different answer.
What'd you get?
2.6
That's what I
times
got.
6.
No,
to the
that's
power 10 up 40.
Didn't do the 40th?
Yeah.
I got 2.8. 9, well, 2.90 we round to the power of 17.
All right, I will say, and this is a big frustration on my part of, at this point, fine. There's some issue with typing, but when it comes to a test or quiz, please make sure you know how to use your calculator and doing the whole exponent thing. So, all of them are way off of the 10 to the 24th that the textbook, that most books will say. So, what is wrong? Let's take a look at units here. What are the units?
Newtons and meters and kilograms.
Oh, now I got.
It's the period in the wrong units, it needs to be seconds.
Yes. Newton is a kilogram meter per second squared. So that would cancel out one of the kilograms. Meters squared. Kilogram. Yeah, that would cancel out one of the kilograms. We'll need kilograms in the end. But that seconds there needs to cancel out with something, the second squared that's built into newtons. And that's in days.
Oh, that makes sense.
So if you did this calculation, you're dealing with funky units. And so if you did this, you would have to keep track of your units. The question has come up several times in several classes of, do you have to write down the units as you go? No, you don't. But if you don't start with nice units, a standard system, then who knows what you're gonna get in the end.
What was the mass of Earth again?
Roughly 6 times 10 to the 24th.
Yeah, I got it now.
Plug it in, what?
I said, it's a big number. 2,419,200 seconds.
Yeah, that's what I got for seconds.
Would that be squared?
And then you would square that.
Oh, really?
And you should end up with somewhere around 6 times 10 to the 24th.
Where did the seconds cancel out though?
A Newton is a kilogram meter per second squared. And so what you'd end up with in terms of units, you'd have meters cubed on top. On the bottom, a Newton is a kilogram meter per second squared times meter squared over kilogram squared times second squared. Second squared coming from this. That would cancel out there. The meters cubed would cancel out with that. That would cancel out with one of the kilograms. And dividing by 1 over kilograms, which pops it up on top. Now notice, no questions on this before I ask you to notice.
Okay, that's even better.
All right, and since I said ask you to notice, would you please notice that the mass of the Earth is equal to this constant right here times r cubed over t squared. That the mass of whatever object is orbiting has been canceled out and it's irrelevant. If I wanted to know the mass of the sun, well, the same formula applies where I just have to pick an object that's orbiting the sun. So I can find, using this, I can find the mass of the sun, I can find mass of the earth, I can find the mass of anything where I have an orbiting object and I know how long it takes for that. I know the radius of the orbit and I know how long it takes. Extending this or manipulating that slightly. I'm gonna put the constants all on one side. So G, mass of, I'm gonna put a little C there for central object, whatever the central object is. Over 4 pi squared is equal to R cubed over T squared. Johannes Kepler took 40 years to come up with his laws of planetary motion. One of the laws was that if you take the orbital radius of one of the planets, divided it by the period of its orbit squared, that is the same for all the planets. Now, we assumed a circular orbit here, which really simplified it. To do it properly, I think I have the links posted under optional. It's heavily calculus based. But in essence, what Kepler spent 40 years of his life doing can now be done in an afternoon using what Newton came up with. Now, one of the reasons Newton's laws were accepted so quickly is the fact that he could derive what Kepler had come up with. Kepler did it not based upon math, but not deriving it, but did it based upon looking at observations of where the planets were, which is an incredible task in and of itself. But I just picture the cruelty skit of if Kepler and Newton met in a bar and they started talking about what they were doing, and Newton says, "So Kepler, what are you doing?" He said, "Well, I've spent the last 40 years trying to figure out these planetary motions." And Newton said, "Oh, you have an afternoon, I can show you how to do that." They did not overlap. Kepler was dead before Newton came along. The other cruelty science skit that I have in mind is the person who figured out Aristophanes, that's not right. Whoever figured out the radius of the Earth, that really close. There's an Egyptian who did it by having a stick sitting upright in 2 different places and looking at the shadow at the same time. And just picturing that the first time he set it up, because there was that one day of the year where it would work perfectly, he set it up and the stick would fall over. Or it was the one day there was a cloud in the sky. So, the perseverance of those people to do that. Anyway, so this is one of Kepler's laws, that for all the things orbiting the sun, that ratio is going to be a constant, and it is actually pretty darn close, even if you bring Pluto into account, which has the most eccentric of the orbits. And yes, I'm old school. Pluto's a planet. And I know it just added to the list of things I just need to get over. But you know what? I'll get over it when I die. This is average orbital radius, and well, period is period. Now, oh no, I can't do the next part until we do energy, so I will wait. How'd it go?
If you were to give this test, or give this question on a test, could we assume that the period is 28 days when you're talking about like the moon moving around the Earth? Or would you give us that information?
I would give you that information, or I would give you enough information to figure it out. Yeah, I would not ask you to memorize that. The one thing that I absolutely will ask you to memorize is coming up.
Is what?
Is coming up.
Like right now?
Quite possibly.
Okay.
Any questions? Other questions? All right, so we've done chapter 6. It's just a matter of levels of difficulty. new topic. We're talking about stuff that definitely is not on the next test.
It's definitely.
Definite, is that a joke? Or are you being
No,
serious?
I'm being serious.
Okay.
We're talking about stuff that is definitely not on the next
Okay,
Okay.
sorry, could not tell there.
I appreciate your asking if you didn't know.